Hey there, welcome back to Code Conyo. So at this juncture, we are going to tackle another encryption and decryption technique. So basically, one of the main problems with simple substitution ciphers is that they are so vulnerable to frequency analysis. Given a sufficiently large ciphertext, it can easily be broken by mapping the frequency of its letters to know frequencies of, say, English letters or English text or English paragraph. Therefore, to make ciphers more secure, cryptographers have long been interested in developing enciphering techniques that are immune to frequency analysis. One of the most common approaches is to suppress the normal frequency data by using more than one alphabet to encrypt the message. So, a fully alphabetic substitution cipher involves the use of two or more cipher alphabets. So, instead of there are being one-to-one relationships between each letter and its substitute, there is one-to-many possible relationships between each letter and its substitutes. So, this is Vigenere cipher encryption. Okay, so uh, in Wigner's cipher encryption, it's actually a method of encrypting text by using a series of different Caesar ciphers that's based on the letters of a keyword. It's basically a fully alphabetic cipher based on using successively shifted alphabets. A different shifted alphabet for each of the letter in our English alphabet. So that's basically 26 letters, which actually the same, or since because it's derived from Caesar cipher encryption. So the procedure is based on the table that is called as Vigenere tableau. So which later I'll be showing to you that one. So with which is if we're going to encrypt, you will we will be using a certain code. So basically, these are non-numerical value. So the letters of the keyword will then being determined as the shifted alphabets that is used for encoding the process. So the Wigner cipher is um, proposed by the Place de Vignier from the court of Henry the Third of France in the 16th century. So it's basically a fully alphabetic substitution based on this table right there. So projected on your screen. Sorry, so sorry for that. So now notice that each of the row of the table corresponds to a Caesar cipher. So look at the first row. Is the first row a shift of zero, which is basically the A. Okay, and then on second, you will notice that these it's shift of one. So all the way from B towards leading towards the A. Okay, and then as you can notice also in the last row, it is shifted to 25, which is by then you will notice that the letter in our uh, last row is basically a Z. So I will be showing you another Vignette tableau, which is a little bit um, visually okay. So we have here. So first row is actually a simple a shift of zero in Caesar cipher. So then second row is actually shift of one, which is we will start with B, and then towards A, and then third row is a shift of two, which is now C towards B, and then look at the last row. It's a shift of 25, which is basically starts with Z towards Y. So that's how it is, or it was created by Vigenere. No? So the Blaze Vigenere. So it's basically a fully alphabetic cipher encryption. So in the next tutorial, we will be doing encryption and decryption. There are actually two ways on how to do it: the substitution and using modular mathematics. So for now, that would be it. And thank you for watching this video and have a great day ahead. Bye bye.